remember I told you that when you have a fraction on both sides, you just cross multiply. So we're going to cross multiply these two here. Okay, we'll do 4 times 12. 4 times 12 is 48 equals x minus 1 times x plus 1. Okay, so 48, and the way I multiply these is that I grab the first term in the first parentheses, multiply it times everything in the second parentheses. So x times x, then the same x times the 1, and then I grab the second term in the first parentheses and multiply it times everything in the second parentheses. Okay, so I'm going to get x times x times x is x squared. X times 1 is just x. It's a positive x because these are both positive. And then 1 times x is a negative x because this one's negative and this one's positive. So when you're multiplying and the signs are different, your answer is always negative. And then negative 1 times a positive 1 is a negative 1 because, again, the signs are different. And when you're not multiplying and the signs are different, your answer is always negative. So I've got 48 equals x squared, a positive x and a minus x equals 0, minus 1, right? 48 equals x squared minus 1. Now from here, I've got to isolate the variable on one side of the equal sign. It doesn't matter if the variable's on this side or if the variable's on this side. It doesn't matter as long as it's by itself. So I'm going to isolate the x squared. So I want to get rid of the negative 1. So I'm going to add 1. I'm going to use the inverse operation. I'm going to add 1. That's going to get rid of the 1 here. But what I do to one side, I have to do to the other. So I'm going to add 1 here. So 48 plus 1 equals 49 x squared. Okay. Now that I've isolated the variable, I use my radical function to figure out what x is. The square root of x squared is x, and the square root of 49, well, does 49 have a perfect square root? Let's see. 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49. Yes. The square root of 49 is 7. So x equals 7. Okay, here I'm going to multiply these two. And remember that when you're multiplying parentheses, you multiply the first term times everything in the second term. So let's do that first. X times x is x squared. And x times 3 is a negative 3x. Then you multiply the second term times everything in the second parenthesis. So 3 times x is a positive 3x, and positive 3 times a negative 3 equals a negative 9 equals 27. Okay. Now I can combine these. Well, a negative 3x and a positive 3x equals 0, so these cancel out. So I have x squared minus 9 equals 27. Now I want to get x squared by itself. I want to isolate it, so I'm going to get rid of this negative 9. So I'm going to add 9 to both sides. If I add 9 to both sides, I get rid of that negative 9. What I get is x squared equals 27 plus 9. Well, 27 plus 9 is 36. Now to solve what x is, I just use my square root function. X squared, the square root of x squared is x, The square root of 36 is a positive and negative 6. That's my answer. Alright, remember I want to isolate the x squared. That's my goal. So I'm going to add 15 to both sides to get rid of this negative 15. That cancels out. What I have left is x squared equals 0 plus 15 is 15. I'm going to square root both sides to get rid of the x squared. That gives me x equals plus or minus the square root of 15. 15 doesn't have a square root or a perfect square root, so I just leave it under the radical. I want to isolate the 3x squared. The first thing I need to do is get rid of this 21. I'm going to add 21 because that's the inverse of a negative, a positive. That's going to give me 0, but what I do to one side I have to do to the other to keep the equal sign true. So 3x squared equals 21. Now I've got to get x squared by itself, so I got to get rid of this 3. Well, this is 3 times x squared. So what's the inverse of multiplication? Division. So I'm going to divide by 3. I've got x squared equals 21 divided by 3. What's 21 divided by 3? 7. Then I square root both sides, use my radical function. What I get is x equals plus or minus the square root of 7.